Hello wonderful person, this is Anton, and in this video we're going to be discussing new discoveries and new observations in regards to the largest structure in the universe, the mysterious cosmic web. Technically not a single object, but a kind of a framework of the universe itself. And so here, based on several recent studies and recent observations from the James Webb Space Telescope, researchers were finally able to show us how this web seems to form and how it dictates the lives of galaxies themselves. But in order to understand the discovery, and in order to understand how ridiculously large this structure is, let's first discuss what exactly is this cosmic web and what do we know about it already. And so basically let's define what we're looking at and what these studies are trying to discover. And in a standard model of cosmology known as the lambda CDM, the universe itself is not some kind of a random soup of stuff or some kind of a random collection of galaxies, and instead seems to be arranged in this very large network of nodes and filaments that sometimes even form these massive sheets hundreds of millions of light years across. And all of this is usually separated by enormous galactic voids, many of which we've discussed in some of the previous videos, with the most famous one and one of the largest ones known as the Bootes void. But in essence, it forms a kind of a giant spider web, where each of the silk threads is made out of dark matter and gas, with each of these threads meeting at certain nodes, which then form what we refer to as galactic clusters, with each of these filaments representing some of the largest structures known to us, even forming something that's in billions of light years across. But until recently, much of this web was more or less invisible to us, and our understanding of this was mostly based on computer simulations, such as the one you see right here, known as the Illustris project. Except that in the last few years, this has also started changing. And a few years back, we started to discuss some of the first observations of this mysterious object, but now in just the last few months, we had some of the biggest news coming from several surveys, including the one known as Cosmos Webb, the largest survey conducted by the James Webb so far, that was now officially discussed in this study led by Hossein Hatamnia. And this allowed scientists to reconstruct an enormous structure based on the James Webb observations, resulting in the image you see here. And this basically goes back in time almost all the way to the Big Bang. This actually shows us the redshift of 7, meaning that we're seeing the universe when it was just a few 100 million years old. And in this case, James Webb is uniquely powerful because it can actually see very faint, low-mass galaxies that were previously missed by many telescopes. But then by combining each of these observations and sort of mapping them out, as you see in this image, it allows us to see the overall concentration of galaxies from some of the more recent discoveries all the way back to approximately 13.5 billion years ago. And here this study discovered a very specific rule, the rule that suggests that the stellar mass seems to follow density. Or basically that in the cosmic history, more massive galaxies seem to be inside much denser threads of the cosmic web, which once again suggests that the cosmic web is not just some kind of a backdrop or some kind of a background. It is an active driver of galactic evolution and seems to be responsible for the formation and the evolution of most of the galaxies known to us, including of course the Milky Way. With the study also discovering that the way that galaxies die, or basically how they stop forming stars, seems to have also changed over time. And that's because in the early universe, above the redshift of 2.5, galaxies mostly stopped forming stars because of some kind of an internal mass reason, such as black hole activity. Basically, most of the early galaxies only stop forming stars when there is some kind of a central black hole that expels so much energy that it stops star formation completely. But as the universe aged and as the galaxies got older, the environment of the cosmic web became much more important, and for smaller galaxies, the web itself started to act as a kind of a killer of galaxies by the redshift of 0.8. Or basically, the web itself started to strip the gas from many of these galaxies. And this usually happened because galaxies entering certain locations inside the web would find themselves in much more dense environments and would basically have all of their gas stripped as they fell into these super dense regions. And without that gas, the galaxies could no longer form stars, which essentially confirms that as the web developed, it started to influence galaxies more and more. But this was just the first discovery based on optical observations, specifically in the infrared. But other telescopes started to find missing pieces of the web even in the local neighborhood, which was previously invisible. As a matter of fact, one of these discoveries even solved a major mystery. And that's because for many decades, cosmologists studying the universe realized that a lot of visible matter was also basically missing. Now, here we're not talking about the mysterious dark matter, we're talking about normal gas and normal dust. And specifically, approximately half of it was actually not visible to us, and nobody knew exactly where it was. This is based on the calculations of mass in the universe and the physical observations, which basically did not match. And while a few months back, in late 2025, observations from the X-ray telescopes like the XMM Newton revealed a massive 23 million light-year long filament inside the shapely supercluster, one of these very massive clusters that essentially represents the connection of several tendrils of the cosmic web. And while first of all the gas inside this filament was extremely hot, approximately 10 million degrees Celsius, but because it was so spread out, it was nearly invisible. And it was actually the heat that finally gave it away. So here's roughly what it looked like. And in a nutshell, this confirms that the missing matter in this case is indeed lurking between galaxies inside of this massive structure or this massive galactic filament, which kind of confirms the simulations and of course solves this somewhat bizarre mystery. So basically, half of the mass of the universe is not inside galaxies, but seems to hide inside the cosmic web. You can learn a little bit more about this in the study in the description. But on top of this, we also have observations conducted in the radial spectrum, basically by using radio telescopes. And so here, at least one study discovered that these filaments are far more dynamic than we thought. And specifically, a study in late 2025, with researchers using the ESCAP radio telescope, discovered that these two dwarf galaxies in the Virgo cluster seem to contain a massive gas bridge at least 185,000 light-years in length. But on top of this is actually actively being formed right now because these galaxies are literally being stripped of their gas as they move toward the cluster, and as the cosmic web, and specifically its higher density, strips the galaxies of this gas and even creates a very long tail that's approximately 1.6 million light-years in length, extending from both of these galaxies. As a matter of fact, this seems to be the longest such tail ever seen. This would be an example of a tidal tail. Here's another famous example from the Tadpole galaxy. And so in essence, this once again confirms that many galaxies interact with the cosmic web, and even right now are actively changing because of the interaction with it. Which actually explains why some galaxies contain these somewhat bizarre shapes and why many of them eventually lose their ability to create stars. But additional surprising discovery in the radio light even found that the web seems to be rotating. We've actually talked about this sometimes last year, but basically here, by analyzing data from the MIGHTY HI survey, astronomers discovered that the filament that's approximately 5.5 million light-years across, and that also seems to contain 14 separate galaxies inside of it, is also spinning. And so for the first time, researchers found strong evidence that these galaxies are spinning inside the filament as they orbit around each other. In other words, this filament is more like a cylinder, and here we're talking about a spinning cylinder that seems to be creating a lot of additional motion that many previous surveys potentially did not consider. And this also suggests that the angular momentum of many different galaxies, or basically the way that galaxies spin, is very likely directly connected to this enormous structure and is potentially created by this structure as many galaxies fall into it, or as many of them form inside of it from all of this gas. In other words, as some of the previous studies discovered, the overall correlation between the rotation of galaxies might indeed be the result of this enormous cosmic web structure. And so here it seems to directly affect the physical shape and the physical environment inside galaxies, with these effects actually being quite profound. As a matter of fact, at least one separate study even discovered that many galaxies seem to be warped as a result of the cosmic web as well. Okay, so let's briefly discuss what that means. Normally we think of galaxies as these very flat pancakes, but many different disk galaxies like the Milky Way are actually warped, so essentially resembling this. And we know that the Milky Way galaxy is definitely warped as well. This has been confirmed by the observations from the Gaia telescope that was able to see slight deviations in star motion in various regions of the galaxy. And while at least one study that examined hundreds of these warped galaxies discovered that their wobble, or the way that they spin as a result of this warp, seems to be not random. Instead, The way the galaxy warps is directly tied to its alignment with its nearest cosmic filament. As a matter of fact, if a galaxy is inside a very enriched filament, or basically the one containing a lot of stuff and high density, it seems to be far more likely to be distorted and warped. Whereas a galaxy that's more or less isolated usually remains relatively flat and does not contain a lot of distortions. And that of course implies that the gravitational tidal forces of the entire universe seem to be also physically bending the shapes of galaxies living inside of it, with the overall discovery and the overall correlation being extremely strong. And so here several separate studies essentially confirm the same. This bizarre structure referred to as the cosmic web or the galactic filament seems to be way more influential than we initially thought. And since this is also a kind of a test of the standard model of cosmology, a lot of these discoveries basically confirm modern cosmology and tell us that the idea behind dark matter and dark energy potentially are correct after all. Mostly because a lot of this does match computer simulations and confirms that our understanding of gravity, dark matter, and the evolution of the universe seems to be on the correct track. But obviously not everything here is perfect, and there are still a few discrepancies here and there. For example, discrepancies in how galaxies cluster or how some of these halos are structured. Which means that additional discoveries will be made in the next few years. But the studies in this case definitely confirm that the cosmic web is not just some kind of a scaffolding that builds everything, it's also responsible for directly influencing galaxies in a lot of different ways, even shutting them down completely or reshaping them and making them spin in a certain way, and in some cases even warping them, making them resemble something bizarre. But now, thanks to the James Webb Space Telescope and new observations in radio and X-ray wavelengths, we're finally moving beyond simulations and predictions to actual physical observations and physical detections, allowing scientists to test various ideas and various theories. On that note, once we discover something else, we'll come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can name it directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.